Hello all, I would like to invite Mr. Avinash Kare to moderate the panel discussion on friction in manufacturing from forming paste to laser beams. Sir, over to you.
Okay, so I will ask Mr. Yashji. See, talking of adaptive control in sheet bending.
Okay.
So, are you contemplating kind of adaptive control for controlling the bend angle of the sheet? Suppose there, due to spring back, the bend angle is incorrect. Can the
Okay.
machine automatically ensure that it will always be correct, despite variability in material properties, despite variability in handling, loading, unloading, and to some extent even the process parameters?
Okay. So basically, as far as now, the what currently that people are using is auto calibration system.
Yeah.
So basically, it is done with the help of lasers. So what
Okay.
eventually happens, there are beams placed across both the sides of your punch. I'm talking about the conventional bending method, not about the panel bend.
Yeah.
So these are placed across the bending dies, and based on it, it evaluates bend, the error in the bend, gives
Mm.
feedback to your system, software corrects it, and then it does the bending and accurate and corrects whatever error there is. So this is technology already there and being used. So this is how people
It's
are
available
achieving it.
now in India in your machines.
Actually, with our machines, I'll be very open with you. For Indian market, the technology has to be economical at the same time,
Of
affordable
course.
and working.
Yeah.
So wherever there is a requirement of advanced technology, wherever there is a requirement of such an application, we definitely have the solution and we can provide. But if I talk about the masses, people
Mhm.
would there are very few who prefer this and not ready to pay the cost of. So yeah,
I'm sure that will change soon because, as Shailendra sir said, that we
yes,
have to catch up with the rest of the world and we can't be left behind. And
definitely,
if we have to
definitely.
compete with others, we have to do what others are doing. Uh, Another aspect which I can probably suggest is, see, I have known panel benders and press brakes having sag correction also. So
Yes,
when you have a big edge pressing, usually there is a sag in the middle.
yes,
So that creates some kind of a problem in precision. So there are
yes,
people who are like having a cylinder in the middle to compensate the sag by
yes,
applying
yes,
a
yes.
different force.
Definitely. So basically, we call it crowding.
Crowding. Yeah.
So there
Crowning.
are type of crownings, maybe hydraulic, maybe mechanical.
Yeah.
So generally, what happens? Actually, we in industry call it bow. Like we who give the machine, we call it bow. So basically,
Bow.
what
Yeah.
happens? As there are
Bow
two
correction.
cylinders on right and left side. So as there are two cylinders on both the sides, there is a bow that happens in center,
Yeah.
maximum in center, and descending on both the sides. So to
Yeah.
reduce
Yeah.
this, we have to increase the base of height
Yeah.
from the center. For that, we have a crowning which is placed exactly, depends three cylinders to two cylinders to one cylinder
Yeah.
based on your machine, based on what you are making.
Mhm.
It creates a pressure in center and
Yeah.
corrects this bow. So this is we have it.
Yeah. Yeah. Okay. It's heartening to note, and I'm sure people who are seeing this one will note that these things are available in India
Yes, 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 definitely.
nowadays. So can make use of them, make good use of them rather. Uh,
Yes.
Thanks, Yashji. I'll come back to you maybe
Thank you
later.
so much.
Sir, uh, one question: if I define something called as precision for manufacturing strategy, since you are speaking about manufacturing strategy and how the manufacturing ought to work, the precision in manufacturing planning, according to me, is something where there is a minimal wastage, there is a 100% sustainability, environmental friendliness, and minimal inventory and just in time kind of a scenario. And even capability wise, we are adaptive and we are ready to take on any challenges which come very fast. So how do you see it happening in India? Is it improving or it is still the same as it used to be some 20 years back?
Actually, the scenario 20 years ago was entirely different. It was more manual, lot many defects, lot many warranties, so many things were there,
Yeah.
and everything was being corrected. Data was not connected. if I really look at today's manufacturing plants, what I used to visit earlier in Japan and Korea, I always used to wonder how these people manage, because I have seen manless factories way back 20, 25 years ago in Korea and Japan, or for
Yes.
that matter in China also. Under one roof, I've seen 1,000 CNC machines running
Yes.
in China in various places. But I never ever imagined that India could really turn its tide and come to this particular level today. And today, when I visit very many manufacturing factories, I'm really surprised, at the same time very, very happy that what factories I saw earlier and today's our Indian factories are absolutely at par. What we are doing today is excellent, and you will not believe that in spite of all these tariffs of
Yeah.
55%, etc., I personally have been experiencing the demand inflow from America, because people have no choice other than
Yes.
coming
Yes.
to India. And that speaks about our prowess in manufacturing. Today, people have acknowledged that Indians certainly had that intellectual capital, but today we also have that intellectual capital being utilized as far as manufacturing is concerned in all the domains of manufacturing. And that is where I said that strategically, if one has to look at it, it is not an option for any manufacturer today. It is a compulsion, or for that matter, it is a need of the hour. And people have been using that intellectual capital in building up their manufacturing setups and completing every function of manufacturing, whether it is supply chain, whether it is human capital, whether it is quality systems, having digital vision measurement and whatnot. Everything what people expected is available here. Of course, there will be time that we will take to really cope up with the kind of facilities which are existing even now in the Japanese or in the Korean manufacturing scenario. But then certainly we have moved on. What we were and what we are today virtually is a generations of change. Meaning, what I always say that what I have seen is the second generation, or maybe the maximally third generation. But today we are talking about the fourth generation. Long back 5 years ago, we talked about
Yes.
fourth generation. After COVID, everyone really jumped onto it. Thereafter, people are now talking about Industry 5.0, fifth generation, where
Yes.
we removed human interference from the Industry 4.0 by making it a cyber physical. Today, human interference is again being incorporated, because basically, I personally feel that humans are innovative, intuitive, and decision making is required by them, because you cannot create a system which can replace the creator. So therefore that industry 5.0 was very necessary, and that industry 5.0 is also leapfrogged by AI induction. And today people are talking about the smart factories using AI, thereby increasing productivity by almost 20-30%, thereby having defect free components, almost 90 to 95% accuracy that we are getting. Downtimes have gone down tremendously, and then energy efficiency, certainly the sustainability part of it has gone up 10 to 20%. So when we are really looking at global platform as the demand center, then naturally we are wise enough, at least in India, I personally feel that we are wise enough to catch up on what is required by the customer side, and therefore we have already prepared ourselves for that. It will take time to match China. Everyone says
Yeah.
that we will try to become China, but then it is very difficult. It will take another maybe 8 to 10
Yeah. Yeah.
years to really cope
Sure.
up with what Chinese are. And naturally, when we are trying to improve on that, they are not going to sit quiet.
Yeah.
It's
Sure.
only the geopolitical situation because of which this opportunity has been open to us. And that has to be capitalized by each and every one of us in the manufacturing sector, which will meet the aims of our government, which has aimed to climb at that third position by getting that contribution, additional 10% contribution in GDP, which really is very, very substantial when we are talking about 5 or 10 trillion dollars.
Right, sir. So another question, while it is very nice to hear about global outsourcing and these kind of big words, uh, India has been accused at times that we are very good at building a house, but we are very poor at building bricks. So, I mean, you understand that we are outsourcing the components, the electronics, the hardware, the sensors, and the nitty gritty of what goes into building a machine or equipment. So we are good system integrators, but we are not making the building blocks themselves, and we are having to import those things. Do you see that scenario improving going further?
Absolutely, sir. Actually, I feel prior to that answering that question, I will go to that make and buy part of it.
Yes.
The economies of the scale will decide the kind of a costing that we will have it. It is not that we can't make it. We will make
Yes.
it, but our prices will not be competitive, which
Yes.
used to happen pre-COVID. I was never
Okay.
competitive when I was really pitching in the international tenders because our scalability was not there. We didn't have that economies of scale. Today, when the
Mm-hmm.
global platform is open, there is economies of scale. Therefore, if we improve the process, if we induct the finances to improve the manufacturing, the infrastructure, then I think we will cope up with all those vagaries very, very efficiently. And today, I will take that example of semiconductors. Once the plugs were put in, everyone suddenly woke up. We have now 3 joint
Yes.
ventures. By
Yeah.
2030, we will be one of the biggest semiconductors manufacturers. Like we are having this investments coming up in various parts of India from overseas, that itself shows the kind of capability or the scalability that we achieve in the shortest possible time
Yes.
because
Yes.
of the intellectual capital or the human capital that we have it, that labor is available, which is very, very cost effective. Intelligent people are available, and those are available in plenty. So therefore, the projects can be exercised or, for that matter, executed in a much, much faster time than anywhere else. And the most important part is that the understanding because of the language. We
Yeah.
certainly have that advantage of language
Sure.
compared to anybody else.
Yeah.
And the currents are flowing totally our way. We have been feeling it internationally. Everyone really, when we used to travel 15, 20 years earlier, the kind of treatment what we used to get and today what we get is entirely different. We are
Yeah. Sure.
enjoying the status that is being bestowed on us today. And I think for that, what hard work each of us have done it in manufacturing is really paying off, and it will pay off if we continue to invest in the
Yes.
manufacturing technologies or the advancement in technologies.
I'm sure, sir, the way auto parts industry has come up over the years recently, I mean, what it used to be and now what it is, I'm sure on similar lines, the other building blocks also will catch up, and the dependence on imported things will come down, particularly in the case
Absolutely.
of electronics and things like magnets and, this kind of
There would
products.
be certain dependencies still remaining because of the availability of raw materials. For
Yes,
example, you
yes.
take electric vehicles. The
Yeah.
lithium 70% production is controlled by Chinese,
Yes,
and
yes.
balance 30% wherever it was, they have acquired those places
Yes.
also.
Yes,
So
yes.
virtually, the raw materials are going to play that end game, and
Hmm.
therefore that dependency part of it is very, very subjective, related to certain components or related to raw materials availability, etc., etc. But
Okay.
given everything in on your plate, the processing that and reaching the goal faster, India can do much better job than anybody else.
Yeah,
I
sure.
personally.
Okay. Thanks, sir. Swamiji, in the laser cutting
Yes, sir.
business that you are, I learned that people overseas are having combo of machines, combo of technologies. They are combining plasma and water jet along with laser in order to cover a wider range of materials, and you load various thicknesses of plates on the same machine, and the machine adjusts the focus and the beam mode and the power, and you can cut in the same program two different plates with two different parameters adaptively, and for lean production as well as for giving a good finish. So are we heading in that direction here also, in case of if you are in know of it?
India, I don't think I have seen anybody getting into that.
Yeah.
Right now, few people where they have they don't have a lot of work on one type of application, and they have
Yeah.
variety of application, and they don't want to invest on a dedicated high-end laser cutting or high-end water jet. Normally, there are some companies who make like a combination where maybe they run one process for a few hours and another process for a few hours. It works in that condition, but somebody who is into really mass production and high volume, that combination, you don't get best of both. I mean, you are compromising on one of those technologies while adopting to the other technology.
Okay. So we have still not become lean enough in that sense that in the same setup we have two different batches of two different materials and the same machine is catering to both.
No, it's nothing to do with lean, sir. It's more of
More
see,
variety,
every
I mean. Because classical mass
variety means
production is out now. Nowadays we have a big variability. There are a
variety.
number of models with the, yeah.
If I want to cut maybe stainless steel less than 10 millimeters, I think fiber laser with high-end laser technology is more efficient. So same thing with the water jet. Like there are certain materials which are better cut on water jet, and there are materials which are better cut on plasma. Anyway, laser is slowly pushing everything out, but
yes,
but it's I think you have to optimize for the application. I think so. Once you mix two, three, then you are really not optimizing for the application, for the exact material thickness, what we are using and all. So then you don't get actually, you will not be competitive in the market for that, for that application.
I don't know, because Europeans have found that as more economical way of doing. I don't know what is the change there, but
okay.
I have seen people doing plasma with laser, water jet with laser, and using them interchangeably sometimes. And
Again,
within the same program, using both of them also sometimes. Yeah. So people are doing that and they have done it, and they have found it economical also. I mean, I'm surprised.
But it increases the capital cost also, sir. Now we
It
have a water
increases
jet
capital cost,
technology,
right.
and also
Probably,
on your
yes, probably,
utilizing
yes.
and your hourly rate to get you on that machine goes
They are
up.
saving. They are saving on loading, unloading time. They are not scheduling. They are loading all the plates up front, and then just run the machine, and which cuts from start to end all the variety of plates which are there, and they get sorted with automation. All those kind of things are there. Yeah.
Maybe there is a small market for it. It's not a general
well,
market.
no, but yeah, that's what I have come across. So I thought I'll check with you.
Okay. Yeah.
Good. Now, anybody wants to ask me anything in the end?
Actually, I'd like to add to the point.
Yeah.
Where you were saying that combining two technology.
Yeah.
So basically that Mr. Swami sir said is totally right. If I combine two technology, I don't get best out of any one of it. But what kind of technologies are we combining? So I'll give you an example. If we combined turret machine with the laser cutting machine, in that case, this combination will actually increase your productivity in a way. I'll give you an example. So for example, I have a job of perforation. So I get the blank cut on laser and I do the perforation part on turret punch. So what happens? My sheet gets bored. If I do the same thing, I put the entire sheet on the turret plus laser machine. I do the perforation first and then cut the blank.
Yes.
In that case, I get the best output. I don't get the bow part. Another is if I have different type of formings and little bit of cutting.
Yes.
So with the combination of these two, first of all, I won't have to have all the tools. So basically, cutting part I can do with laser, which will help me avoid lots of normal standard tools.
Yeah.
So these combination will definitely work
the
best together.
It works.
But joining plasma and laser, I don't think so will give you the best output.
Not plasma, but water jet and laser definitely I have seen. Plasma and laser also I have come across. Yeah, I have seen. And not recently, way back in 2016 or so. In some expo, I have seen that kind of machine as well. So people are doing various things. They are trying various things. Probably something is of academic interest that yes, we can do it. Something is having the economic backing that yes, it's a justification that it will work also. Any other questions, or shall we close it?
I have a question for you.
Yeah.
And how has fiber laser technology changed the economics and performance of laser cutting compared to CO2 fissions?
Compared to CO2?
CO2 fissions.
No, CO2 had flying optics. So the lenses and mirrors used to get deteriorated. Their coatings used to go due to thermal evaporation. due to condensation of oil from gases, etc. So it was difficult to maintain. It was costlier to maintain. It was more capital intensive. But there were some plus points in CO2, that it was the best machine for cutting steels. Because for cutting steel, somehow the wavelength of 10.6 micron that CO2 has is still better than any other wavelength. Yeah, it kicks out the molecules of steel just like that cold sublimation. Yeah, so for that it is best. CO2 is best. Now fiber is a good general purpose laser where you can have more variety. Okay, it is not as optimal as CO2 for cutting plates, but then it is cheaper, it is more maintainable, it is more modular. To that extent, yes, it makes economical sense. Its costs have come down over the years as compared to CO2. Yeah, so that has become the choice of industry. Somehow it has become it's from based on economics and availability criteria. But there are issues in fiber laser transmission, particularly if you have a big trim line and you are having big torsional stresses coming on the fiber can give way and laser can come out from the wrong place, and then it can hurt somebody. So there are hazards also sometimes. So CO2 flying optics has its own plus and minus points, of course. But that is a technology which has matured over the ages since 1988 that I know of it till recently. Now people have developed a liking for this one, fiber and disc laser and diode laser and all those other variants which have come, which are more or less in the same band as fiber laser. But fiber laser has become much more modular, cheaper, easily available. So that's what I would say.
Yeah, thank you, sir. And so, Vyas, I have a question for you. Like, how can panel blenders completely replace press breakers in modern fabrication shop?
Not actually. So basically, panel bender and a press brake go together hand in hand. Panel bender have a limitation with thickness, but has a possibility to get the job done way faster. So the combination of two, or maybe there are some bends which can not be done on a panel bender. There are some type of jobs which cannot be done on it. So if both the machine combined together in a set can actually help you achieve productivity at a higher rate. So it goes together. It's a combination. Has to have both.
Yeah. It's just how many we like to have your views as well. If you could highlight something.
So
yeah. So any other questions? So it was good. It was a pleasure hosting all of you, and it was an enjoyable discussion. And I'm sure we'll meet in some other talk show some other time soon. Bye bye. Good day. And
thank you. Thank you so much.
Thanks OEM Update for organizing this event. And bye bye everybody.
Yeah. Thank you, panelists, for thank you, panelists, for exchanging your valuable thoughts on today's application in manufacturing, from forming quest to laser build. We hope you enjoyed the session thoroughly. Before wrapping up today's session, we thank our speakers, Mr. Swami Mago, Mr. Selindra Goswami, Mr. Yashwar, and I would also like to thank Mr. Avinash Khare for taking this initiative. And we request our delegates and viewers to stay tuned for more such sessions. Thank you and goodbye.